Okay, hey y'all. We are going to, where did it go? I do not know why it closed. We're going to actually do another example of synthetic division. It's going to be slightly different as far as what it asks for. The method is still the same. There's just going to be an added step. For this problem, we're asked to find all zeros using synthetic division. Lazy, SD. So using synthetic division, we're going to find all zeros. What we're asked to solve is x cubed, a negative 2x squared, a negative 23x, a positive 60, close your parenthesis, divide that by x minus 4. So already y'all know, I didn't change colors, but I know I need to set this equal to 0, which is going to just give me 4. And I'm going to bring down all of the coefficients. And what I have here is a 1, a negative 2, a negative 23, and a positive 60. I do this, I do this, I do this. Okay, so what we do here is we bring our first term down. I know I have a 4 here, and then we start our multiplication. 4 times 1 is 4. That's a positive 4. 4 combined with a negative 2 gives you a positive 2. 4 times 2 is 8. That's a positive 8. And then we combine there. Signs are different. You subtract. Keep the sign of the larger. If you do your multiplication, I get 4 times 15, which is going to be 60. Signs are different, so it's negative. I find here that I have additive inverses, which means when I combine them together, I get 0. So our dividend was our 4 terms. Our divisor is the x minus 4, and our quotient is what I write here. The quotient is the answer to a division problem, right? So I know that I have 1. It started with x cubed, so it actually goes down. The exponent goes down by 1 number, so I get x squared. And then I have a positive 2. It was x squared. Now it's just x. And then I have a positive 15. It was x. Now it's no x. Okay, so that's my quotient. So because it told me to find all of my zeros, I'm actually going to use my dividend, divisor, and quotient to rewrite this. I'm going to do it first in the, this is the answer way, and then I'm going to show you something. Okay, so that was my quotient, right? What I divided was, favorite color, so I'll use it. What I divided was x cubed negative 2x squared, a negative 23x, and a positive 60. I divided that by x minus 4, and the answer to that was x squared, positive 2x, and a negative 15, right? Let me see, like a real world type of example. If we had 60 and I divided it by 10, I would get 6, correct? Okay, so let's say I wanted to kind of rewrite that as a multiplication problem. I could do 60 equals 10 times 6, correct? Those are saying similar things. I basically could just rewrite it. So what I'm trying to say here is that my function, my polynomial, can actually be written in a specific way where you have your dividend and it equals your divisor multiplied by your quotient and any remainder that does happen to exist. Here there was no remainder. Okay, so I'm just going to erase this though as far as space is concerned. Let me do what I said, which is rewriting it. So I would have I no longer need parentheses because it's not multiplying to anything. I would have x cubed negative 2x squared negative 23x positive 60 equals. If I multiply these two terms, right, just like that 6 and that 10, sorry, I would end up getting back to that 60, even though it originally was a division problem. So I know that what I could do is write that original problem as a product of my quotient and my divisor. Okay, so I'm going to go ahead and we're going to call this star because we're going to recall it in just a second, okay? So in order to find all zeros, to find all zeros, what we're going to do is set f of x, which is my function, equal to 0, and we're going to factor. Doing this allows us to actually figure out the individual values of my x's, and that way what I end up doing is finding my zeros, called zeros because it's what makes the function 0, right? We've definitely seen something like that before. So I have, what do I have? I have the function x cubed minus 2x squared minus 23x plus 60, right? That's my f of x. And this told me to find my zeros, I'm going to set my function equal to 0. Now, it tells me to factor. Okay, so I have 4 terms, and I could possibly, no, I couldn't even factor by grouping. 23 and 60 don't even have any common factors. Instead of making it too complicated, just recall star. I know that a division problem could actually be written as a product of a multiplication problem. So I'm literally going to use that fact right here. In star, I said that that left-hand side equals the right-hand side, correct? So I'm going to go and show you here in purple. I'm actually going to write it as the product of my divisor and my quotient. Those two terms right there. It's going to be equal to 0. Now, doing this, it actually doesn't take much guesswork. I'm not questioning, can I, should I, could I? I literally am seeing these two factors. I've got x and a minus 4, and I got that trinomial x squared plus 2x and a negative 15, and those are equal to 0. Well, what I would do is set both of those factors equal to 0. Actually, I need to simplify that trinomial some more. So I do have my x minus 4, and then if I factor this, I know I need x's here. I know that 15's factors are 1, 15, 3, 5. Multiply to a 15, but give me a positive 2. So that would mean my 5 is going to be positive. So now I have these 3 factors set equal to 0. I have definitely solved a problem like this before. Setting them all equal to 0, I would get that x equals 4 and x equals 3 and x equals a negative 5. So in any type of homework you may see, probably ask you or, just to list the zeros. And so it doesn't necessarily matter what order you list them in. The set of zeros would be 4, 3, negative 5. Okay, so I have another problem that I want to do. It doesn't tell me to find all zeros. It's actually one where we need to make sure we have all of the variable terms. So I will do that in another video. If y'all have questions, make sure you ask, okay? Thanks. Bye.